So today we are going to start new chapter. Excited?
Yes, sir.
Very interesting chapter, and basically now physics has started. All that was child's play that we were doing, dimensions, kinematics. Yeah, kinematics was, we can say, sort of physics, but properly now the physics has started, laws of motion. Okay, so first of all we are going to start from the basics. As you know my methodology, we are going to start from basics and we will go to the topmost height. If you face any problem anywhere, do not hesitate and ask me. You all know it. So first of all, what is force? Now see, name of chapter is laws of motion. We have already studied motion in kinematics. Now, when motion is there, so what are the laws that govern the motion? Yes? How is motion governed? How is motion occurring? Okay, we have seen many equations of motion, but those were the equations when motion has started. First question is that how motion starts, how a body starts moving. That's the basic question, yes or no? Now, Shokeen is standing at his place, yes, and he is eating ice cream. He is not moving, he is not in motion. Obviously, his what is not changing? Position is not changing with respect to time, so he is not in motion. Okay. And mind you guys, no one prompted me, no one said anything. What's happening? I don't understand. Why didn't you all tell me about a topic that I left? Inertial and non-inertial frame has been left, but no one has stopped me. Why? You don't know inertial and non-inertial frame, haven't heard of it, huh? Say something, why are you hesitating? No one has stopped me, no one said, sir, one topic is left. Actually, I have left that topic intentionally. I will do that topic after forces. Okay, my modus operandi is quite different. Okay, so I don't go in accordance with the textbook. I go in accordance with the logic. So, inertial and non-inertial frame will be more clear to you when you do forces. I have left two more things: relative velocity, aeroplane problems and boat problems. That too I will do after the forces. Okay, clear everyone? Any doubt? Yeah. So I will not leave anything, don't worry about it, that's my responsibility, but I will do in the preference order of logic, not of the textbook. So my question was, yes Shokeen, you are standing and suddenly I come and I see that you are eating a very good ice cream and I start envying you and I push you so that ice cream falls off from your hand. Now when I push Shokeen, he stumbles. Stumbling you all know? Yes or no? Okay, he moves forward and then he falls down on his face. He breaks his two teeth. But what happened is that this boy changed his position with respect to time. So he came into motion. Tell me yes or no. This boy came into motion. Now what was the cause of the motion? Sir, ice cream was the cause. You got jealous of ice cream. No, ice cream was not the cause. The push that I imparted him, that push made him move. Yes or no? Everyone? Yes, Shokeen, what happened?
Yes, sir.
Yeah. So keep on speaking. The push enabled this guy to move. So actually, from this example, what we observed is that body will not start moving autonomously. There will be something, some action will be there that will make the body move. Make the body move. So, no body no body, B-O-D-Y, starts moving on its own. No body on this universe. There is some external agent that causes the motion to occur. Tell me yes or no. Agreed or disagreed? Hello Avni. Right. Now, we have studied force in class 7th, I think. Yes or no? First time we studied force in class 7th? Forces.
Yes, sir.
Yeah. Guys, keep on speaking, else I will get the impression that you have not passed class 7th. Okay. So you have studied force in class 7th. And in 7th they told you push or pull is a force. Yes or no? That's what NCERT said. NCERT class 7th. Push or pull is a force. Hello, what I did to Shaukin, I pushed him. I pushed him. Yes or no? What was it? So it is a force, yes or no? Push or pull is a force. I applied force on Shaukin. So, the relevance of this is that motion got initiated when force was applied by an external agent. Motion got initiated when force was applied by an external agent. And what is a force? For now, we know that push or pull is a force. One more thing, twist is also a force. Okay. Now, me and Shaukin get into a fight. I don't like him, so I get in fight with him. So what I do is, I hold off his hand and I twist it. I twist his hand, trying to break his hand. So what am I doing? Am I not applying force? Am I applying force or am I not applying force? Shaukin, am I applying force on you or not? I am twisting your hand.
Yes, sir.
But push or pull is a force. I am neither pushing nor pulling you. Then how am I applying force on you? Because twisting is also the effect of force. So we will add twist also. You drink cold drink and then you crush the can from your palm. You twist it, yes or no? That is also exertion of force. Okay? So push, pull and twist is a force. All these are the forces. Okay? So this is the most grassroots level definition of force. Kindly note it down. Done?
Yes, sir.
Everyone? Okay. So, this force, it can be categorized into 3 categories. Yeah. Can you tell me the names? Forces are of 3 types. Can you tell me the names? Sheetal. Non-contact, contact. Okay, these are 2. Yes, Shaukin. Reshma, Shanmukha, Pujita, Avni. Types of forces. Shaukin, you don't know types of forces, huh?
Balanced force, unbalanced force.
No, that's not the most primitive type. That's not the most primitive type. All these three types can be balanced and unbalanced. But these are the most fundamental three categories in which force can be classified. Okay. So the names that I am going to tell you might be possible that you have not heard those names. Number 1, field force. Number 2, non-contact force. And number 3, hinge force. Kindly note it down. Field force, non-contact force and hinge force.
Sir, field force and non-contact force are the same thing.
Oh, sorry, I had written non-contact. Contact, sorry. Done? Now what is a field force? So see, as the name suggests, field. So once I will get into electrostatics, field thing will become more clear. But to give you overall idea, have you heard of cricket field? Yes or no? Cricket field.
Yes, sir.
Okay. So what is done in cricket field? Cricket is played. So field is the name for an specific area where a particular task is performed. Yes or no? A particular type of task will be performed in the field. Cricket field means cricket will be played in the field. Hello? Yes or no? Getting my point? Similarly, if charge is present, so there will be a field of charge and a specific area where charge will exert its effect. A specific area where charge will exert its effect. Yes or no? So that area where effect of the charge is prevalent, that area will be known as electric field. You keep a magnet. You take two magnets. Pay attention. Look here, everyone. You take two magnets. Hold the magnet. One in your left hand, one in your right hand. Now, hold these hands apart like this. Stretch out your hands and hold the magnets. Now, slowly move your hands closer to one another. So, initially, when you are holding magnets at the length of an arm, these magnets are not attracting or repelling each other. But slowly, once you start moving your hands together and you are trying to bring the magnets close, what will happen? A point will come when these magnets will either pull or push each other. Yes or no? They will either attract or they will repel each other. Tell me yes or no? Guys, yes or no? Very common phenomena. A point will come. You are bringing them close. A point will come. Suddenly they will attract or they will push each other. Why? Because initially these magnets, the magnets were exerting their magnetic field, but there is a specific area till which magnetic field has got its prevalence, till where magnetic field exerts its effect. Once you brought them close, their magnetic field interacted with each other. Yes or no? Because distance got reduced and then the effect was shown to you. Yes or no? So the area is there. a particular area where the effect can be observed. This area is known as field. This area is known as field. Yes or no? Guys, yes or no? Suppose,
Yes.
suppose this is a tree. And this is a leash. With a leash, you have tied a dog. Now my drawing is too pathetic, so don't comment on it. How to make dog? Yeah, this is dog. Yeah. So this is the tail. These are the legs. Okay. Now, Shaukin, are you scared of dogs?
No, sir.
Okay, Avni is scared, I think. No, no one is scared. So, Shaukin is not scared of the dogs, he comes here. And he is teasing the dogs. Okay, like this. Yeah. But dog, since dog is attached to the leash, as you can see, so dog is not able to show its effect to Shaukin. Okay. Dog is attached to the leash, so dog has got its own area. Till that area, dog will be able to exert its effect. But Shaukin is beyond that area. That is why dog is not able to do anything. Now, I come and I see that Shaukin is teasing the dog. I push Shaukin and Shaukin reaches at this point. So once Shaukin reaches A, dog will show its effect in various forms to Shaukin. Yes or no? Because Shaukin has entered the field of the dog. Tell me yes or no. Guys. Right?
Yes, sir.
So, I hope the word field is clear to you now. Right? These are the layman examples that I am giving you. Don't write these examples in your notebook. That Ankit Shaukin will be bitten by a dog and all that. That's a field. Now, field force. So the forces that are experienced once you enter their field. Magnets exerted force on each other. They pushed each other or they pulled each other. When? Once their field interacted, once you entered their field, you keep the magnet and hold iron at a distance of, keep a magnetic bar and at a distance of 10 meter, hold the piece of iron. Magnet will not attract iron. But once you approach closer to the magnet, a point will come when magnet will attract it. Why? You have entered the magnetic field. So now, once you enter the field of such, what are the field forces? These are those forces that once you enter their field, then forces start acting. Once you enter their field, forces start acting. Is it clear or not? Everyone?
Yes, sir.
So that's the proper definition of field force. Now tell me one thing, guys, pay attention. Tell me one thing. In field force, is it necessary that you have to touch a body to experience the force? Should I touch the iron with the magnet to experience the magnetic force? Should I?
No, sir.
No, sir.
Should Shaukin touch the dog to get bitten by a dog? No. Just push the Shaukin to the field of the dog. Dog will automatically bite the Shaukin. Yes or no? So, touching is not essential, not even required. Okay? That is why field forces are also known as non-contact forces. See, if you will give this name, field force, to a kid who is studying in class 7th or 8th, everything will be a bouncer for him. Okay, so to teach the toddlers, the term non-contact force is there. The proper term is field force. Understood? So synonym for field force is non-contact force. The real name is field force. Understood? So no contact is essential. Okay, you can give examples. Magnetic force, right? Electric force, the force that Coulomb uncle gave to you, remember? Don't you remember Coulombian force? Hello, F is equal to K.
Yes, sir.
Yeah, then speak. Okay, Shaukin, where are you at present? In your room you are sitting, right? So,
Yes, sir.
are you exerting weight in the downward direction? Weight is also a force.
Yes, sir.
Force is equal to mass into acceleration. So Shaukin has got some mass and acceleration is acceleration due to gravity with which Earth is pulling Shaukin towards himself. So weight towards itself, not himself. So weight is also a force. Now tell me Shaukin, force is force exerted by Earth on you. Your weight is field force or not? Everyone, your weight is field force or not? Is it contact force or not? Or non-contact force? What type of force is it?
Non-contact.
Sheetal is saying contact, Shaukin is saying non-contact, Shanmukha, Reshma, Avni, what do you guys think? Shanmukha thinks non-contact. Reshma, Avni? Yes, it is non-contact. See, here, Shaukin is sitting on the chair. But, imagine if you have got a tree again and an apple is attached to the branch of a tree. So do you mean that since apple is not in contact with the earth, so gravitational force will not be acting on the apple? Or do you think apple won't have any weight because it is hanging? Is it so? Yes, Sheetal. Apple will have weight even though it is hanging, even though it is not in the contact of the earth, but still apple will have weight. Right or wrong? Right? So contact is not essential for the exertion of weight. Therefore, weight is also a non-contact force. You can write gravitational force also. Understood? Please note down this much. Done?
Yes.
Everyone? Okay. Moving on, contact force. So what is contact force? Contact force I will do in the next page. Yeah, contact force. So what is contact force? When two bodies are in contact with each other, then the force they exert on each other is known as contact force. You all know it. The point that you need to understand is that this force will be equal and opposite. What I mean is that if two bodies are in contact and one body is exerting force on another body, so another body will also exert force on the first body, and these forces will be equal and opposite to each other. Okay. Point number 2, if the surface is frictionless. What is friction we will see later, but I hope that you have got basic idea that what friction is. Anyone who doesn't know at all what friction is? So everyone knows what friction is. Pujita, you know what friction is? Okay. So if the surface is frictionless, if the surfaces are frictionless, then contact force will be perpendicular to the normal reaction. If the surface is frictionless, then contact force will be perpendicular to the normal reaction. Now see, suppose I have got two blocks. I will explain everything. Wait. Now these two blocks are kept on each other. Let me name them. Let me call it A and let me call this block as B. So two blocks I have got, A and B. They are kept on each other, one over another. Right? Now what you are trying to do is, you are trying to push block A. You are applying force on block A. You are trying to push this block. So when you will push this block, so what will happen? As these two blocks are in contact, a force will be developed. Block A will offer resistance to block B. Yes or no? And this resistance force, which is offered by A to B, it is in the opposite direction of the force applied by you. Tell me yes or no. You are applying force towards right, so frictional force will get developed towards left. This is the friction offered by block A to block B, towards the movement of block B. Yes?
Yes, sir.
Okay. Right? So if you are applying force in this direction, let's say capital F, so a frictional force got developed in the opposite direction. Plus there will be one more force acting here. there is one more thing. Please see. B has got some mass. Block B has got some mass and Earth is attracting it. So mg is acting in the downward direction. Yes or no? Weight of block B is in the downward direction. Now pay attention. We have just studied that if weight is acting, or if what is weight? Weight is force. If force is acting or force is applied on a body, so what happens? Body starts moving, motion happens, motion occurs. I pushed Shawkeen, Shawkeen started moving, motion was there. But block B is applying a force in the downward direction, but still block B is not moving in the downward direction. Block B is at its place. It is not changing its position. Why? Yes, why? Everyone agrees with me or not that block B is applying weight in the downward direction? Yes or no?
Yes, sir.
Then, and weight is a force. Tell me, weight is a force. Yes or no? So if force is applied in a particular direction, then why isn't this block moving in the downward direction? Why?
So the force applied is not more than the required force.
What required force?
Greater than the static friction.
Static friction. Friction that you are talking about, it is acting in the horizontal direction. I am talking about the vertical direction.
There are pseudo forces applied in the upward direction.
Pseudo force. Pseudo means non-real. Pseudo is non-real.
Yes, sir.
Non-existent. So you mean that there is some imaginary force, and due to that imaginary force, this body is not going down. That's what you are saying.
Normal force is acting.
Normal force is acting. Very good. That's the correct answer. Please see. There is a force known as normal reaction. This. Why is this block not going in the downward direction? See, block B is applying its weight. Block B is applying its weight on block A. Downward direction. But still, block B is not going down. Why? Because block A is also applying a force on block B. Block A is also applying a force on block B. Equal and opposite force. Equal and opposite force. And this force which block A is applying on block B, this is your normal reaction N. Clear or not?
Yes, sir.
This is your normal reaction N. So, everyone studies normal reaction. Whenever they draw FBD, they always draw normal reaction. But if you ask them, they will not be able to explain that what actually normal reaction is. But I hope that now it is clear to you. You can explain to anyone that what normal reaction is. Why aren't you getting down to the earth? Why don't you get down to the earth? You are also applying force on this earth. You are standing, sitting, sleeping, lying, whatever you are doing. You are applying weight in the downward direction. Why aren't you going down? Because if you are sitting, you are applying weight on the chair in the downward direction. So chair is also applying a force on you in the upward direction. That's normal reaction. Okay, everyone?
Yes, sir.
Please note it down. Done? Yes or no?
Yes, sir.
Okay, everyone done? So I am erasing it. I want to make some changes. Another thing I want to discuss now. So now what I am going to do is, suppose this is your block A. This is B. Suppose you are applying F1 force on A and F2 force on B is applied. Getting it? Two blocks are kept. You are pulling one block towards the right and you are pulling one block towards the left. Like this. Yes? Now, can you tell me separately what all forces will be acting on block A and B, and can you also tell me the direction in which these forces will be acting? Can you or can't? Yes, Shokeen.
Yes, sir.
Okay. Shanmukha, you tell me. Open your mic, Shanmukha. I am drawing A. Yeah. Now tell me what all are the forces acting on A and their direction also.
Sir, weight is acting downwards.
Okay.
Normal force upward.
And only two forces. What happened, Shanmukha? Where are you? Avni, you tell me now. Sheetal? Pujita? Anyone? Shocking, can you tell?
Sir, towards the right and frictional force.
Towards the right. My right, this here.
Yes, sir.
Which force?
Friction.
Friction. Okay. So we are let's denote friction by small f. So small f. That's what you are saying, Shocking.
Yes, sir.
So according to Shocking, this will be the scenario. Is it right? Yes, girls. This is right or wrong? So, what will act on left? Reshma, complete sentence, dear. Frictional force on left. Okay. Okay, this. And what is on right then? What is on right? This force that I have applied, F1. Shocking, what has happened to you? Come on. Very good, Reshma. Alright, see. Now see. Imagine yourself to be sitting on a block. Go and sit on the block. Now see. Block is being pulled. Hello. Block is being pulled towards the right. So what will you experience? If something is getting slided over an object, what will you experience? You experience some resistance from the surface or not? Some jerk is there, some resistance is there. Ground is offering some resistance. That's what friction is. Yes or no? So, you are pulling this block A towards the right. So, friction will act in the opposite direction, that is towards left. You are pulling this towards right. So, block B will offer resistance in the opposite direction. I have not told you first law, but what is first law? You have studied it million of a times. First law is a body continues to be in a state of rest or of motion until and unless exerted by an external force or external unbalanced force. That's the proper law. So body does not want to change its position, but you are applying the force. Since you are applying the force, so it's the tendency of a body that an opposite force is there, which is trying to stop the motion of this body. Yes or no? Hello? And if you want to go to the depth, look here. Everyone, pay attention. Why does frictional force gets developed? This is the surface of block A, which you are observing. But if you will look at it microscopically, so the surface is something like this. And the surface of B is like this. You know, all spiky. So once these spikes, you have kept A over B. So bottom of A and top of B, they both are spiky surfaces. Now you have kept one over another. Now when you will push A, these spikes will get interlocked. Hello, that's what's going to happen. Now when they are interlocked and you are pushing, so what will happen? It will resist your movement, right? It will resist the movement of the block, and that is why it is so tough. Or you can not so tough initially, but still it is tough. This is what resistive force is. This is what friction is. Got it or not, everyone?
Yes.
And that's why they say apply the lubricant. Why are you applying the lubricant? Once you apply the lubricant, what happens is these are the spikes on the surface. You apply the lubricant. So what happens is lubricant reaches this empty portion and it fills it. So basically lubricant is labeling it. Yes or no? Film of the lubricant is labeling the surface. The spiky surface now got turned into even surface. So once spikes are reduced, interlocking will be reduced, thereby friction will be reduced. Got it or not? That's why if you spill oil on the floor and walk on that floor, you will fall down. You will trip down. Yes or no?
Yes.
So anyway, once we do friction, we will discuss all these things. I am just giving you basic informations, nothing else. Now can you draw? Who will draw for B? Yes, B. Yes, Shocking, you tell me for B. B.
Sir, F2 in left.
F2 in left.
friction in right, wave in downward direction.
Yes. What
Arm
else?
normal from ground to upward direction.
Yeah, stop for now. Let's not go into more details. There will be other forces also. Weight of B is also acting, but I don't want to complicate it for now. Okay, so only 4. Fine. Clear or not?
Yes, sir.
Yes, sir.
Please note down this much. Let me know when you are done.
Done.
Okay. Okay. Moving on. Now this was the first type in contact force. Second type, when bodies are attached to one another. So if you have got two bodies, let's say M1 and M2, so how are you going to attach these two bodies? How are you going to attach these two bodies with one another? Now don't say Fevicol or don't say Fevicol or Fevikwik. In another batch, one student said, sir, we will attach them by a Fevikwik. Yeah, we can use strings or we can also use springs. See, you can attach them like this also. Connect a spring to both of them. Now they are attached. Right? Or you can attach.
We can give them opposite charges.
My God. If you will give them opposite charges, so it is not significant, it is not necessary that they will come and they will stick to one another. There are other factors that govern whether they will come and get attached to one another or not. Anyway, once we will do electrostatics, I will tell you that also. Don't worry. So for now, we can attach a string or we can attach a spring. So under this category, two type of forces we have to deal with. One is your tension force and another is your spring force, and it is K into X. We will see what that is later. So if you are using a string, then tension force will be there. If you are using a spring, then Kx will be there. Understood? Note it. Okay?
Yes, sir.
Now, let us deal with them one by one. So, talking about this tension force. Suppose you have got two masses, M1 and M2. Okay. And I give acceleration A to this mass M2. How will acceleration get developed? Can anyone tell me? How will acceleration get developed? I am saying that I have given acceleration A to mass M2. How A got developed? How can I directly give acceleration to a body? Yes. Hey, come on guys, what are you doing? You have read about forces in class 7th, 8th, 9th, 11th. So many years, still you don't know.
So by applying force on M2.
No need to feel bad. That's the same situation with 95% of the students. They don't know because it is not mentioned in the books and it is not taught to them. Cramming is done, question solving is done. And that too stupid questions. Anyway, always remember, please pay attention, and this will get a lot clear once SHM is done. So remember this, that acceleration is the byproduct of force. Acceleration is byproduct of force. Yes or no? If you will
Yes, sir.
If you will put a fire on heap of wood, wooden sticks are there, heap of wooden sticks are there, and you put them to fire, what will happen? Ash, you will get ash. After it is burnt off, ash is a byproduct. Yes or no?
Yes, sir.
If a thing is done, if an action is performed, you always get a byproduct. So byproduct of force is acceleration. So if force is acting on a body, acceleration will automatically get developed on that body. Force, remember this, force, it was asked in JEE. Force does not provide velocity. Hello? Force is not the cause for the velocity. Force provides acceleration. Byproduct is acceleration. If you don't know, you can write it. That acceleration is the byproduct of force. Write it in these words. Clear, everyone?
Yes, sir.
Now tell me, you are applying acceleration on M2, as you can see. What will be the acceleration on M1? If I am applying M2 on acceleration A on M2, small a, what will be the acceleration on M1?
A.
A. Are you sure?
Yes, sir.
Yes, girls, what do you think? Reshma says A, Sheetal says A, Shanmukha, Pujita, Avni, A. Pujita, A. A. Now listen to me. If the string is inextensible, same acceleration gets developed in all the masses attached to it. Attached to it, I am talking about a string, okay? Attached to it. Please read this and tell me, are you able to understand anything or not? Read this statement that I have written. Yes. Read.
Yes, sir.
So, did you understand anything?
Yes, sir.
What do you understand? Tell me.
Sir, if the ends of a string are attached with two different masses, then both will have same acceleration.
No, my dear, no. It is inextensible. Yes, Reshma, what did you understand? Shanmukha, what did you get? Tell me. Let's say whether
uniform distribution.
uniform distribution of what, dear?
Uniform distribution of accelerations.
No. When will the acceleration be same? It is saying that when the string is inextensible. So what is the meaning of it that the string is inextensible? Yeah.
Where force is the same.
No, dear. Look, I am telling you. Can you see it? Can you see something in my hand, a string in my hand? Can you see it or not? This black color. Say yes or no. Can you see or not? A string. No? We can see. Shocking, why don't you speak when it's important to speak, huh? Okay, see. Inextensible means, see, I am pulling this string. But this string is not changing its length. Extension. Extension means what? increment in the length. Hello. Inextensible, which this means that on the application of force, if the length of the string is unaltered, there is no change in the length of the string on the application of the stretching force. Even if you are stretching the string, its length is unaltered, length is not changing. Okay, then such a string is inextensible. If the length of the string does not change on the application of stretching force, then such a string is inextensible. Got it or not?
Yes.
Yes, sir.
So, if your string is inextensible, if the length of the string will not change on application of force, then the acceleration developed on all the masses will be the same as it was on the single mass. So, if this string is inextensible, so here also in mass 2 also you will get an acceleration A. Yes or no? If you attach a third mass to it, M3, here also acceleration will be A. You attach infinite masses to it. A question was asked in NEET. You attach infinite masses to it, acceleration will be same. It will be A in this case. Understood or not?
Yes.
Note it down. Understood? Done?
Yes, and
Please note it. Now, answer this. What will be the acceleration of M2?
our acceleration will be same, but will be upwards.
Yes, acceleration will be same. Why? Now see, nothing was mentioned in the question that your string is extensible. So if nothing is mentioned, we will take it as inextensible, and if a string is inextensible, then same acceleration gets developed in all the masses attached to the same string. So this mass M2 is attached to the same string, thereby acceleration A of same magnitude got developed in it. Understood?
Yes.
Note it, then we will move ahead. Proceed. Can I proceed?
Yes.
Okay. Let me give you some questions. Let me see. Okay. Do this. Okay, do this. Easy question. Tension developed across mass m1 is T. What will be the tension across mass m2? Tension across mass m2. Yes? Sheetal is saying T. Ankit?
30.
Reshma? Note down one thing. Second point. If the string is massless, then tension developed across all its masses will be same. So for tension to be same, this string has to be massless. So if this string is massless, then tension developed will be T, same, else it will be not. Okay? Understood? If a spring is massless, then this will be the case, else not. Understood?
Yes, sir.
Now, tension is going to be the same. This factor tension is going to be the same across the both ends, this factor is not only governed by string. There is one more factor which will decide that whether the tension is same across both the ends or not. So what's the second factor? This was the first point. Second point is your pulley. If pulley, and here also two factors are there. Number one, pulley is massless. Number two, frictionless. If pulley is massless and frictionless, then tension developed across both ends of pulley will be same. So pulley has to be massless and frictionless. So please see, if I call this case A, so in case A, I can say that your string is massless and pulley is massless and frictionless. That's why same tension got developed. If I take the same case, okay, case B, and let's say that your string is massless. Pulley has mass. Pulley has mass. But no friction. So pulley is not having any friction, but pulley is having mass. So what will happen? So if tension T1 has got developed here, then tension T2 will be developed here. Understood? Yes or no? Ankit Shaukin, are you getting it or not? You are not speaking.
Sir, what is the role of mass of pulley here?
What is the role of mass of pulley here? If pulley has got mass, then this string, weight of pulley will also get exerted on the string. Yes or no? So now the reactional force offered by string will differ. Yes or no? This is also going to exert its weight.
Yes, sir.
and that weight is balanced by the string because pulley is attached to the string. So now, and what is the tensional force? Tensional force is the reactional force offered by the string. So now what will be the weight attached to the string? M1 plus mass of the pulley. So tensional force will differ. Yes or no?
Yes, sir.
Understood now or not?
Yes, sir.
Everyone? Now see, third case is also there. So again the same diagram. M1, M2. T1, T2. Now different tensions are acting along the same end and the same mass. T3, T4. See, the string is not massless. Pulley is not massless. And third, there is friction between string and pulley. And all the tensions will be different. Got it or not?
Yes, sir.
So that is why in the questions that you must have solved in your class 11th, the assumptions were given that assume string to be massless, assume pulley to be massless and frictionless. Yes or no? Have you seen this or not?
No, sir.
You have not solved questions of class 11th, huh? No sir, I did not study in 11th. Huh? Okay, if you have not seen, no problem. Now, if you will open the books, dear, of these pulley and string cases and read the question. So in question it is always given that assume it to be massless. But if you will open some very good books, S.C. Verma, Resnick and Erdo, so in those books some questions will be there when they will say that a string is not massless or pulley is not massless, there is a friction, then every tensional force will be different. So those are two complicated cases. Got it? Now just imagine how will you frame the equations. Four tensions are there, and by the use of single pulley, 4 tensions are there. And weight is also there of mass 1 and mass 2. So many accelerations will be there. Okay. So this is JEE level advanced. It is way beyond NEET. In NEET, you won't even get this. Even this is tough for you all. But we will do both of these. We will do even third also. We will not leave anything. We will do third also. But for you, this will be the thing in your domain. Understood? Everyone?
Yes, sir.
Now, second I told you spring force Kx. Yes or no? So
Yes, sir.
spring force we are going to discuss in detail in work, power and energy, not here. Then I will tell you about spring force. Okay. Tensional force we will discuss in FBD. Spring force we will do in work, power, energy. Note it down. And that's it for today. I will see you in the next class. Have a great day. Bye bye. Take care.